Hey, what's up, guys? Welcome to Metasploit Mega Primer Part 3. In this specific video, we will look at Metapreter basics and also the usage of STD API. First of all, thanks a lot for all the encouraging comments you left behind in Part 1 and 2, and I hope you like Part 3 as well. Okay, so in the previous video, what we saw is how to use different payloads such as add user, bind a shell, so on and so forth, right? Now, what are the limitations of using specific payloads? Well, first and foremost, these specific individual payloads generally can only do singular tasks. For example, the add user payload can just add a new user onto the system. It cannot do anything else, right? Bind shell to a port just goes ahead and binds a shell. No other task can be achieved. Maybe, of course, you can run a couple of shell commands available to the command interpreter, but that's all you can do. Now, even though most exploits include a remote shell creation in their payload, there are certain disadvantages by doing this. First and foremost, the creation of a new process may trigger an alarm on the remote system, specifically if that has host-based intrusion detection system. Also, for CH rooted apps, which is applications which are kind of jailed, if you know what I mean, even the execution of the command interpreter may not be possible because in that CH rooted jail, the command interpreter may not be even accessible or available. Last but not the least, even if you have a shell, you're limited by the commands the shell itself can run. So as you can see, using specific payloads has a lot of disadvantages even if you use a remote shell. So what do we need? Well, the ideal payload first of all should avoid creation of a new process, simply because this will ensure that no alarms are actually triggered which will make AVs or any sort of IDS suspicious about what is happening. Second, this should actually run in the exploited process's context itself. Third, it should not create any new files or anything on the disk, simply because doing so triggers AVs into action. Now, what is required on top of this is basically that this payload provides a platform which the attacker can easily extend at runtime. What we mean by that is additional functionality can be added as and when required at runtime itself. So in the previous case, even though we had a shell, well, all we could do is what the functionality the shell offers. In this case, our ideal payload would actually be a platform which is extendable at runtime. Finally, it should also allow for writing for scripts that can leverage the platform. This will ensure that a lot of people can probably use these core APIs and write scripts which can leverage these APIs to do multiple tasks. Well, I guess all your prayers have been answered, and this is exactly what the Metapreter is. So quick Metapreter basics. Well, Metapreter is actually meta interpreter and is a post-exploitation tool. And the way it works so that it can go ahead and avoid the whole process creation, writing to disk, etc., is by using in-memory DLL injection. Well, lately also reflective DLL injection is available, but we won't worry about that as of now. And using in-memory DLL injection and native shared object format, it is able to do the magic as what is required from the ideal payload we discussed. If you're unaware about what DLL injection is, view this video by Prasanna K about DLL injection basics. It's a very good video, and I think that should clear your doubts. Moving on, the Metapreter as required does not create any files on disk. Even better, it communicates between the server and client, which is the victim and the attacker, using encrypted communication. It provides a platform for writing extensions as well as scripts. Finally, it is very stable because it has been kind of time tested, flexible and extensible, right? Couple of other points. When you use the metapreter, you will actually see that it resembles a command interpreter. It ships with a set of core commands which you can use totally out of the box, and it can be extended at runtime by using extensions which work by shipping DLLs to the victim. Also, there are a large number of things you can do with the metapreter, including command execution, registry modification, file system access, and many others. We will discuss a lot of these in course of this video series. So how does this all work? Well, very interestingly, once the exploit succeeds, the first stage payload is executed. The payload now connects back to the attacker's MSF instance, and the MSF instance goes ahead and sends the second stage, which is what is responsible for the DLL injection. It also sends the metapreter server side DLL, which is required on the victim. Now, once the DLL starts running in memory, both the client and server, which is the attacker and the victim side, communicate. From there on, depending on what is required, other extensions can be loaded as DLLs, and many other things are possible. Okay, so I guess a lot of theory, and without further ado, let's go ahead and look at an actual demonstration of using metapreter. So let's quickly visit our familiar setup. Well, this is the Windows XP machine which is vulnerable to the RPC DCOM vulnerability. This is the backtrack instance we are running, right? I'm running both of them on low RAM. That is why I'm not using the GUI on backtrack. What I'll do is I've connected with an SSH session to the backtrack instance, and I've already run MSF console. So the first thing I use is selecting the exploit itself. Right, this is the MS03 26 DCOM exploit. Quickly go and have a look at the options. I set the remote host. Quickly check the IP address of the vulnerable instance here. It says 1.3. Right. The next thing I need to do is set the payload. Hit tab twice. You get the whole list of available payloads. Now I'm going to use the Windows metapreter bind TCP, which is it's going to bind to a remote TCP port. Right, I'll just have a look at show options again to ensure that all the options are available. So this is going to bind to the port 4444 of the remote host. Right, after this we go ahead and run the exploit command, and if you notice is the DLL is being sent, and now we have a metapreter session which is open and it lands us into the session. So this is how the metapreter client side utility looks like. Now this will go ahead, connect to the server side utility running on the victim and send various commands from the attacker's machine. So very quickly we can just type in the question mark to look at all the different commands available. To begin with, you have a set of core commands. Now let's look at some of these. Background goes ahead and puts the current session into background, which is, if I go ahead and type in background, well, I'm back to my whole exploit prompt, and now I can run other exploits, etc. on the same or other machines. Now if I want to go back to my metapreter session, I first type in sessions-L to look at available sessions. Then I do a sessions-I and select the metapreter session I want to connect to. Right, so I'm back to my old session. Now moving up, There are a lot of things we can do. These are more concerned with running Metapreter scripts in the background and a couple of other things. We won't worry about that right now. When we visit Metapreter scripts later on in a video, we will look at these commands. Channels and channel related commands we'll just visit in a little bit of time. Now, a couple of other interesting commands. IRB actually drops you into a Ruby scripting mode where you can actually go ahead and type in Ruby, commands which the Metapreter will go ahead and execute. Now, we will look at this when we do programming using Ruby for the Metasploit platform. Right? So let's look at this command called migrate. Now, what migrate does is it migrates you to a new process. Now, before we do that, let us also look at a couple of other things before we rush into it. Well, by default, the STD API extension is loaded and the server-side support DLL is already running on the victim. So STD API has a couple of different command sets. The first is file system, then you have networking, then you have system commands, user interface commands, and depending on what the exploit has, let's say the exploit goes ahead and gets high privileges, then even the priv extension is loaded by default, or else priv is not loaded, only STD API is loaded. Right, so let's first quickly go ahead and try out some simple commands. Now let's first look at the networking commands. Now remember, all of these commands are going to run on the victim. So we have three commands: ipconfig, route forward, and route. Let's run each one of these. So I'm typing in ipconfig first. So this gives me the remote server's IP address configuration. Right? Cool. The other is actually route, where we can give a -h to look at the possibilities. For the time being, just look at a list of all the routes. So this is the list of all the routes on the remote machine. Now, interestingly, later on we will visit a concept called pivoting, in which we may even go ahead and add a couple of routes on the local machine in order to be able to access other subnets through different gateways. We'll look at this in a very comprehensive way later on. Do not worry about it right now. The last networking command is port forward, which is for port forwarding. This will also come in handy when we actually do pivoting, right? Just be aware the command is available. Later at an appropriate time, we will use this command. Okay, now quickly going back. System commands are very interesting. Now let's take some of the more useful commands. So once you've broken into a system using an exploit, the first thing you would want to figure out is who exactly are you running as, in the sense which user account is the current Metapreter session running as on the server. So for that, we simply use the get_uid command. So if you notice, we have been very lucky. We are actually running with the system account privileges, which is huge. Now, apart from get_uid, you can also look at what is your process ID on the victim, which is 792. Now, one of the interesting commands which is available in the core functionality is migrate, right, which we said we're going to look into. Now the question is, into which other process would you want to go ahead and migrate the server-side Metapreter DLL into, right, which typically happens using DLL injection. Well, to figure that out, we would need a list of all the existing processes. Now that is made available using the ps command in STD API system command set. So I type in ps and I get this huge dump, right? And if you go ahead and remember, our PID was 792. So if we actually go down and search for 792, here we are. This actually means we are running in the process space of SVC host. right? Very interesting service. Now we can go ahead and migrate to some other process. So let's say I migrate into explorer.exe, right, which is going ahead and running as the user Vivek on the machine. So depending on the privilege level of what we are currently, you can go ahead and migrate into a different process. So why migrate? The big question, right? Well, a lot of times what might happen is the service you have broken into on which the exploit has successfully run might crash after some time, or it might hang, and the user might go ahead, turn off the service, or even turn off the program if we compromise the user space program. Now the issue is the moment that happens, well, even the meterpreter is actually wiped out of memory because it is just residing in memory as a DLL. So this is why you quickly need to go ahead and migrate into a new process space after breaking in to a victim, right? So now we migrated into explorer.exe. So we don't have to worry if the SVC host instance we broke into is going to crash or something else is going to happen. Okay. Coming back, let's look at a couple of other commands. Right? So we had a look at get PID and we had a look at get UID. Now we also looked at PS and migrate. The interesting thing is you can also kill a process. Right? So how would that work? Well, let's say that we have the command.exe prompt running right now. We can just go back here, type in PS once again, and if you notice there are command.exe is running as the user here, right? So this has the PID 1012, so we can use the kill command, figure out what the options are. Oops. Where basically I can just go ahead and give the process ID. Now if I go back to my Windows instance, if you notice, command.exe has been killed and has exited. Right? Coming back, if you can scroll up, what are the other interesting system commands? Well, reboot is going to reboot the machine. Reg is a way to go ahead and interact and modify the remote registry, which we will look at later. There are a couple of commands here with tokens. Well, we will visit this in the next video set where we first understand what tokens are on Windows systems, and then we will look at drop token, rev to self, which is revert to self, etc. Right? Now, or steal token, etc. Now, one of the other interesting commands is sysinfo, and after that we look at something called shell. Sysinfo gives all information about the remote computer, which is the name of the computer, the operating system, the build, architecture, and the language information. Right? So now, before we go ahead and move to shell, we look at some of the other commands. So we've visited the networking commands and the system commands, most of them. Before going forward, let's look at the file system commands. Now, STD API has a really powerful set of file system commands. We'll go through a couple of these. So one of the first things you would want to know is what is your current directory on the remote system, right? And this is where you can go ahead and use pwd. So if you notice, the current working directory seems to be C drive documents and settings Vivek. You can use the cd command and change the directory. And now if I go ahead and do a pwd, you would notice I am in the root or C drive. I can look at all the files here by using the ls command. Now all of these are part of the file system commands made available by STD API. Now you notice that this is similar to what you would actually see uh, when you do a simple ls minus L or hyphen L, sorry, on a Windows, on a Linux system, right? So interestingly, there seems to be this file called confidential.txt. So if you want to view this file, you can just use the cat command and give the full path. Interesting. So if you notice, there is a credit card number here, CVV and expiration date. Well, I guess you'd always been warned against storing important sensitive information in the clear on your drive, and this is one of the reasons why it is such a bad idea. Now, going back, we've looked at cat. Well, cd and del is very simple. Del is to delete a file. You can download a file also by using the download command. So as an example, you can just say download, give the whole give the whole file path, and this will go ahead and download this file locally, right? Now if you move up in the whole list of commands, you can also edit a file by using the edit command. Now how would this work? Well, you just type in edit and you go ahead and give the file name. Sorry, it was just a right, edit, and let's say I want to edit confidential.txt. I just type in this command. So if you notice, this seems to be the remote file. Now let's say I go ahead and add hacked you at the end, right? Don't worry about this error message. We can actually go back and view the file, and if you notice now the string hacked you has been appended. We can go to the remote server and verify this as well, right, that the file has actually been modified. So going back, most of these commands are quite self-explanatory, right? I'll just take up one more command in this entire set, which is the search command. So search allows you to search for different files on the remote system. So very interesting. What I could do is search, give it the directory from where it should start searching, give it some sort of an expression for the types of file. By default, what would happen is it would do a recursive search and just give it, let's say, doc. Now it is searching for all doc files on the entire system beginning at C drive. So if you notice, these are all the doc files available on the remote system. Now very simply, I can go ahead and use the download command to download these files, right? So as you notice, the Metapreter is giving you a lot of flexibility to do various tasks, which, as you can imagine, with just a shell, you would have had a very tough time doing, right? So we've looked at the system commands as well. Now comes in the user interface commands. Now in user interface, there are a couple of commands relating to desktops, which we will look at in the next video, because there is some technical background you need to know before we can move to these commands. Now, interesting commands here include these five actually. First is idle time. Now, idle time tells you how long the remote user has been idle, in the sense since how long has he not interacted with the system using his mouse and keyboard, right? After that, three of these are useful for remote keystroke sniffing. right? So keystroke capturing very easily happens using these commands. So it's very simple to enable them. All you have to do is key scan underscore start. It says starting the key scanner. Go back here. Uh, Let me go ahead and let's say fire up Internet Explorer and go to gmail.com, and then I'll go ahead type in my username, and let's say I type in some password. Of course, when I try to sign in, it might not work because it's not the right password. Now here, if I go ahead and do a key scan underscore dump, you would actually notice that the entire keystrokes which I went ahead and entered into the remote machine have been captured. So first I entered gmail.com, hit a return, wrote Vivek, hit a tab, went ahead, deleted the existing password, wrote the new password ABC123, right? So very powerful remote keystroke capture. Now let me go ahead, stop this service, right? So now going back to the set of commands, we looked at a lot of core commands, file system commands, networking commands, these system commands, and user interface commands, right? Now, what we will do right now is quickly go back to the presentation and learn about one key concept and come back. So communication between the Metapreter client server is entirely encrypted and is in the form of TLVs, which is type length value. So inside the whole encrypted communication, data is getting transferred either side using TLV packets. Also, because of this, there can be multiple channels of communication which can be used, as TLV easily allows for tagging of data with specific channel numbers. Now, what is the advantage? Well, this allows multiple programs running on the victim to communicate with the attacker at the same time. Right? So let's have a look at what we mean by this. Right? So there is a specific command called execute. So what we'll do is we'll go ahead and execute a command prompt and actually say we want channelized IO. So it says channel 8 created. Let me hit that once again. Channel 9 created, channel 10 created. So if I want to look at all the available channels, well, I can just go ahead and hit a channel hyphen L. So if you notice, now I have 3 channels of type std API underscore process which have been created. Now if you want to interact with these channels, you can do a lot of interesting things. Let's say you just want to read from one of the existing channel as to what data is being sent. So you can just type in read and then the channel number. Right? So as of this point, there is no data which is available on the channel. Similarly, you can actually try on other channels. So basically there is nothing currently there. Now you can also go ahead and interact with any of these channels. So let's say you hit interact and give a channel number, let's say 8. Right? So if you notice right now we are on to the command prompt. If you do a dir here, you would actually notice this is nothing but C drive of the machine with our confidential.txt file also seen, right? So one of the things we can do is exit from this channel, then we can again type in channels hyphen L. When we did exit, well, the whole channel terminated because the server-side command.exe process actually exited, right? You can also go ahead and write to a channel. So you can actually have a look at what you would like to write. And you can go ahead and write that as well. So here is one interesting example. Let's say you want to write to channel number 9. Now go ahead, write something. So let's say I want to ping google.com. It says enter data followed by a dot on an empty line. So I wrote 16 bytes to channel 9. So ideally what should happen? Well, a ping process should be invoked which should ping google.com. If I want to look at what really happened, I can just try to read on channel 9, and it just read the data available, which was 511 bytes. And if you notice, this is actually telling me that the ping command was written, which is what I typed in, and this is the response to that command. So what is the beauty? Well, if you notice, you could actually have multiple processes running on different channels on the server, which is where the victim is, and then you could actually switch between channels and do a lot of stuff. So let's say you're doing an attack which requires multiple programs to be enabled, and it requires you to interact with all of those programs, right? Maybe you're running a port forwarder somewhere, you're actually going ahead and running a remote web server in the other terminal, and you want to manage all of this. Well, channels is the answer. You can go ahead, run these different processes on different channels and switch between them in order to get the control terminal for those channels. Or even better, you can send data to all of those channels without even having to interact with them, right? Finally, if you want to close a channel, you just use the close command along with the channel number, right? This closes the channel. As you see, it says no active channels currently available, right? So let's quickly go ahead and have a look at what we did. In the core commands, we had a look at almost all of these commands, including channel, interact, close, etc. The two commands which are actually left here are of course read and use, which we run and use, which we'll have a look in a bit in the next video probably. The rest of the stuff we've had a look at. File system commands, we've had a look at almost all the file system commands. Networking, all commands. STD API, most commands apart from those dealing with tokens. User interface commands, all commands apart from those dealing with desktops and user interactivity, right? So going back to our presentation, well, Meterpreter has multiple commands and extensions available, and we had a look at some of the core commands, and also we looked at STD API and the different file system, networking system commands it made available. The priv module was also loaded, but we did not have a look at exactly what the module offers. Other extensions are also there, which we will look at in a while. Right, so STD API, quick recap of all the different commands. Okay, so this is all I had in mind for part 3. So in this session, a quick recap. What did we do? Well, we learned how to go ahead and set the Meterpreter as payload and actually go ahead and successfully run the Meterpreter server-side DLL and connect to it from the attacker machine. After that, we looked at a lot of core commands and then moved on and looked at the STD API extension and all the commands it offers. Now, we looked at most of the commands apart from those dealing with tokens and desktops, which we will look at in the next video. So well, that's all for this video. I think this was very heavyweight, quite long, more long than I had imagined, but I wanted this session to be as comprehensive as possible, and that is why I spent so much time with the basics and STD API. I would really appreciate if you can leave a comment behind whether good or bad, if you feel it was too long, or whether you feel this was absolutely as comprehensive as you wanted it to be. In the next video, we will actually look at commands offered by STD API which use desktops and tokens. We will also look at other extensions using including incognito, priv. At the very same time, we will also look at Meterpreter scripts and how to execute them. Well, that's it. Late in the night here. Hopefully, you're going to have fun watching this video. Thank you. Bye bye.